This is Mr. Thompson with another calculus lesson. This time we have moved on to Chapter 2. We are Lesson 2-1, Numerical Approach to the Definition of Limit on page 33. Now this section is pretty short since limit should be a review, so it just basically jumps straight into some exercise problems. So we're going to go ahead and take a look at problem number 1 right there on page 33. Now problem number 1 first gives us the function. We have f of x equals 2x squared minus 5x plus 2 all over x minus 2. And it gives us a graph. If you look there in the book, you can see it better, but I'm going to go ahead and draw a simple one. We have the upper right-hand quadrant. Graph looks somewhat like this. There's a little open circle there, and then continues 2 and 3. All right. So that's what it gives us, and then it asks us some questions. First of all, it says, show that f of 2 takes the indeterminate form. So we need to discuss real quick what an indeterminate form is. So we'll do that by plugging 2 into our equation. So we have f of 2 equals, so across the top, 2 squared is 4, times 2 is 8, minus 5 times 2 is 10, plus 2 over x 2 minus 2, we get 0 over 0. Now 0 over 0 is what's called indeterminate form, because you can't have 0 divided by 0. That's just impossible. Now, this also explains to us why there is an open circle in the graph. It is an open circle because it's indeterminate form. This is not actually a value. Alright, this is not a value. It's indeterminate. That means we have an open circle there on a graph. Now, part B says the number y equals 3 is the limit of f of x as x approaches 2. Make a table of values of f of x for each 0.001 unit of x from 1.997 to 2.003. Now, easiest way to do this is on a calculator. So I'm going to go ahead and take my calculator, and I'm going to plug in this function. So across the top, 2x squared minus 5x plus 2 divided by x minus 2. It says we want to start at 1.997 and we want to count by 0.001. Let's go ahead and take a look at our table. 2.994, 2.996, 2.998, error, 3.002, 3.004, 3.006. So that error is what happens when you have the indeterminate form. That is why there's a circle there. If I hit graph, it's not going to pop up as an error, but we got to know that there is not a value right there at 2 and 3. Now, C asks us, so I'm going to go ahead and put for B, C calculator. You would have to copy it down, but for now I'm just going to put C calculator. Part C says that how close to 2 would you have to keep x for f of x to stay within 0.0001 unit of 3? How about within 0.00001 unit of 3? How could you keep f of x arbitrarily close to 3 just by keeping x close enough to 2 but not equal to 2? So basically we want to see how close it gets depending on what we're counting by. So in part B it had us count by 1/1000th, and we came within 2 1,000ths. So let's count by 1/10,000th. If we're at 1/10,000th, and probably should have gotten a little bit closer to start with, that's alright. 1/1000th away from 2, and we are 1/10,000th away from 2, and we are 2/10,000ths away from 3. So I'm going to go ahead and put that down here. So if x is 1.9999, y is 2.9998. 1/10,000th away means 2/10,000ths away. So if we try 1.99999, my guess is we're going to have 2.99998, just following the pattern that I see. So let's go ahead and try that out. Start at 1.9999, oops, I think I messed up somewhere in there. 1.99999, and counting by 0.00001. Well, this is going to automatically round for us, so I guess we can't really see that through the calculator. But my guess is it's going to be 2.99998 if we actually plug it in and see. Alright. Part D says the missing point x equals 2 is called a removable discontinuity. Now, we can break this apart because it asks us why do you suppose this name is used? Well, the name is used because it is a discontinuity. Discontinuity means it is not continuous. That means there is no value there, so discontinuity. And it is removable because we can rewrite f of x and get rid of it. So I'm going to show you that over here where I still have some room. So if I factor the top, let's see what I get. 2x, let's see, minus 1, x minus 2. And double check that that works. Negative 1 times negative 2 is 2. 2 times negative 2 is negative 4, plus negative 1 is negative 5. 2 and 2 make 2, or sorry, 2 and 1 make 2. So that works, and then the bottom is still x minus 2. It is removable because we can get rid of that, and now our function is just f of x equals 2x minus 1. We have removed the discontinuity. Written like this, it has no discontinuity. Written like this, it has a discontinuity. If I were to plug this into my calculator, find it real quick, where'd it go? Not sure where my calculator went. Gotta load up a new one. There we go. If I plug in as my equation 2x minus 1 and hit graph, it looks the same. Set up my table. That's fine. Starting at 0, counting by 1s. If this were the other function at 2, it would have error. On this one, we don't have an error. It now says 3. So we removed the discontinuity. That is why it's called a discontinuity. Now, that's all there is for lesson 2-1. It's pretty simple. Limits are a review, and that's mostly what this chapter is about. So no problem set from this one because the lesson is the problem set.